Silicon Valley built its empire promising that with enough data, human behavior is perfectly predictable. But an audit of cloud metadata shows a statistical void where models break down, leaving an uncomputable spark of chaos at the center. To train these predictive models, the tech industry relies on scraping massive datasets. They harvest petabytes of search queries, location pings, and digital interactions, assuming that the sum of our past can calculate our future. Yet even at that scale of information, machine logic hits a forensic gap. It can track where a person goes or what they buy, but it fails to map the sudden, non-linear leap of a truly original idea. Algorithms are hitting an invisible wall. They are attempting to use deterministic math to solve for a biological process that is inherently unpredictable. The data used to scale these models is running out of human input. By 2025, over 74% of new web pages contained AI-generated material. Roughly 40% of the web is now synthetic. This creates a recursive loop where new AI systems train on the simplified outputs of the generation before them. This leads to model collapse. As algorithms iterate on their own data, they oversample likely patterns and permanently delete the tails of the distribution, the creative outliers. Without those outliers, the AI produces content that is narrow and homogenized. It becomes a system that only repeats the average of its own previous mistakes. Scaling the compute power no longer helps. The system enters a state of digital self-cannibalism, trapped beneath its own algorithmic ceiling. To break through that ceiling, machines historically relied on brute force. Silicon computing depends on massive hardware to process rigid, linear logic. The modern energy cost to maintain that logic is becoming unsustainable. A single large language model now consumes 9 megawatts, enough electricity to power a medium-sized town. In contrast, the human brain coordinates 100 billion neurons to perform creative tasks that no silicon architecture has yet replicated. The brain achieves this immense parallel processing on an energy budget of just 20 watts. Brute force mathematics cannot explain this efficiency. It forces us to investigate the specific biological anomaly that allows a 20-watt light bulb to outthink a power station. Unlike a computer chip, the brain does not operate by firing its circuits with deterministic precision. Instead, it relies on presynaptic stochasticity. This is a mechanism where synaptic connections frequently and randomly fail to transmit a signal. This deliberate failure is exactly what makes the brain efficient. By operating with high uncertainty, the neurons reduce the metabolic cost of every thought. This uncertainty creates resting state fluctuations, a background noise constantly present in our neural pathways. When this noise collides with learned data, it disrupts the probable outcome. It forces the brain to bridge unrelated concepts, creating a non-deterministic leap of logic, the specific mechanism of an original thought. Machines are designed to eliminate this noise. They aggressively filter out randomness to ensure that 2 plus 2 always equals 4. But that pursuit of perfect logic is a creative dead end. True human ingenuity requires the organic chaos that silicon is built to destroy. Silicon Valley assumed that human behavior was merely a complex equation waiting to be solved. But because algorithms are based on rigid math, they cannot extract or replicate the probabilistic chaos of our biology. This biological chaos functions as an impenetrable natural firewall. It resides in the physical cells of the brain, beyond the reach of predictive models. As artificial intelligence struggles with its own recursive synthetic data, the human mind remains mathematically uncomputable. Dive deeper into the hidden secrets that shape our reality. Click the subscribe button, activate the bell, and see you in the next scientific investigation beyond the boundaries of reason, only on Tembodocs.